The objective of this experiment is to determine the Ksp value of a lightly soluble salt. The Ksp value is the value of the solubility product constant. The solubility product constant is an equilibrium constant for a solid compound that is soluble or insoluble, in this case in water. The insoluble compound that we're using is silver chromate. This silver chromate we're going to actually prepare experimentally, and as I'm showing you in this reaction down here, we're mixing potassium chromate. It's an aqueous solution of potassium chromate with an aqueous solution of silver nitrate, and when you combine those two, you have your ionic exchange, and now you're getting as a product the silver chromate. Silver chromate, it's an insoluble compound. It's insoluble in water. So that's the actual compound that we're forming, and then we're trying to dissolve to determine the concentration of the ions in solution and finally calculate the Ksp value. The numerical value of your equilibrium constant, or Ksp, is giving you a lot of information. As part of that information, you can determine if a substance is very soluble or it is mostly insoluble in water. The larger the value of your equilibrium constant or your value for Ksp, the more soluble that substance is. Since our silver chromate, it's actually classified, looking at the solubility rules, it's classified as an insoluble compound. You should expect a numerical value really, really small for that Ksp that you're calculating. So I have here my table, is the ice table, just showing you how your silver chromate dissociates into ions. When your silver chromate, every mole of silver chromate that dissociates, it's giving you 2 moles of the silver ion, 1 mole of the chromate ion. So writing down your Ksp expression just by looking at the dissociation equation, you have the concentration of silver is squared because you have a coefficient equal to 2 in front of your silver ion, and then you have your concentration for your chromate ion, and that one is to the power of 1 because your coefficient is 1 for your chromate ion. So just solving your ice table here, your initial concentrations are equal to 0. You're getting the ions from the dissolution of your silver chromate in solution. Now the change is how much you're expecting, how much or how many ions you're expecting to get in solution. We're using letter S because that's your molar solubility. So we have 2S, and that's a positive sign because you're actually forming those ions. So remember, since these ions are being formed when your silver chromate is dissolving, we use the positive sign. A 2 in front of your S because your coefficient is equal to 2. For the chromate, it's just S because your coefficient is equal to 1. So in equilibrium, we have the initial concentration plus the change that will give you the concentration at equilibrium. So it's 0 plus 2S, that's just 2S, and then you have 0 plus S, which is just S. If you plug in your concentrations at equilibrium into your Ksp expression here, you're replacing the concentration for silver, Ag plus 1, to S, and then you have your chromate, which is just S. The square remains there, and then you have just S. So your Ksp here will be equal to 4S cubed. Solving this first bracket here where you have the concentration of silver squared, that will be 2 squared, which is 4S squared times S. When you do 4S squared times S, that will give you 4S cubed. So what you're actually getting in this experiment is that molar solubility, or that S value. If you have the value of your molar solubility, then you can actually plug in that number back into your equation, and you can calculate the numerical value for your Ksp. So we are going to do that by determining the concentration of the chromate ion in solution. We're going to have a set of standard solutions that we know the concentration. We're going to measure the absorbance for those solutions, and we're going to prepare a graph. That graph is what we're going to be using to find the concentration of your unknown solutions. So when you have your unknown solutions, you're going to determine the absorbance for your unknown solutions, and then you're going to use your graph to find those absorbance values. Let's put just one here. Let's say that that's my absorbance for the unknown solution, the one that I don't know how much chromate it's in there. You move from that absorbance to the line. From your line, now you move to the x-axis where you have concentration of chromate, and that's how you determine the concentration of your chromate ion in your solution, the one that we're preparing with my solid silver chromate, and we're actually trying to dissolve that silver chromate to get the chromate ion in solution. We determine the absorbance, and now we're using that absorbance to find out the concentration of that chromate ion in the solution. In this video, I'm going to show you a demonstration about the experiment determination of Ksp for a slightly soluble salt. The slightly soluble salt that we're using is silver chromate. The first thing that we have to do is to prepare a calibration curve. We prepare a calibration curve using standards that we know the concentration. So we're preparing our standards using potassium chromate. Potassium chromate is this yellow solution that I'm showing you here. And we're preparing just 4 standards. We're using specific volumes from this solution here to prepare our standards. The first one we're preparing using 250 microliters. The second one 500 microliters, the third one 750 microliters, and then the last one 1000 microliters. To prepare the standards with these specific volumes, we're using a micropipette. So with the micropipette, we are taking the volumes that we need. We're transferring the volumes into your volumetric flasks. And then we're completing the volume in your volumetric flask using distilled water. The volumetric flask that we're using, they have a total volume of 10 milliliters. Since we have to determine the concentrations of our standards, to determine the concentration of the standards that I am preparing here, we need the concentration of your solution for potassium chromate. We need the volumes that we're using from our initial solution here, and we also need the final volume. With those 3 numbers, we can calculate the concentration of the final solution, which is the dilution. And we're using the dilution equation to find those concentrations. Once we have the standards, we're going to measure the absorbance. We want to prepare the calibration plot. And for the calibration plot, what we're graphing is the absorbance versus the concentration. The concentrations we can calculate. The absorbance is the experimental data. So we use the spectrophotometer here. It's already set up at a wavelength equals to 375 nanometers. It's already calibrated using distilled water as the blank. And then what we have to do is just to put our samples in the cuvette and measure the absorbance for our standards. Since we have 4 standard solutions, we're going to have 4 values of absorbance, one corresponding to each solution. Our solutions, the concentration is increasing because we're adding a larger volume of the potassium chromate in the last standard that we're preparing here. So you have your 4 data points for the absorbance for these 4 standards here, and you're calculating the concentrations for them, and you can prepare the plot. Now, we're preparing the graph because we're actually trying to determine the concentration of this chromate ion in an unknown solution. That unknown solution that we have is just a solution that we're preparing by dissolving silver chromate. The silver chromate is insoluble, so we're trying to determine how much of that insoluble compound is actually dissolving in water. And with those concentrations, we can calculate the equilibrium constant, or the Ksp, for this silver chromate compound. To do that part, what we have, I'm going to remove this here. We have to first prepare our solid. And to prepare the solid, we're using silver nitrate. Silver nitrate is a soluble compound, and you have a solution of silver nitrate here. You have the concentration for silver nitrate here in the label. And now we have our solution here for the potassium chromate, which is the one that we use to prepare the calibration plot. Also, you have the concentration for the potassium chromate solution that we're using. It's right here in the label. When we mix these two solutions are aqueous because both compounds are soluble in water. When we mix them, we get our insoluble compound, silver chromate. So this compound that we're forming here, it's a solid, and we're transferring that one into a centrifuge tube. We're centrifuging the sample that we have here to separate the solid from the solution. Now, after we do this step here, we're going to remove or as much liquid as we can from the centrifuge tube, leaving the solid behind. What we're trying to accomplish with this step is to remove any ions that are remaining in that solution that we have, or chromate ions, because when we're measuring absorbance for this sample, we want the absorbance from the chromate ion that it's coming from the dissolution of the solid that you have here. If there are some chromate ions in your solution that are just from your potassium chromate solution, we want to make sure that those ions are not present, affecting our measurement. So we precipitate the solid, we remove as much liquid as we can, and we add this to water, we centrifuge again, and we're just rinsing the solid. And when we remove the liquid, what we're doing is removing any ions that are present in solution. After doing that for a couple of times, we're going to add this to water to our sample. And now what we're doing is shaking our centrifuge tube for 15 minutes periodically, so it's not constantly shaking. What we're trying to accomplish here is to actually dissolve some of the silver chromate that you have to get some ions in solution. So we do that, and we centrifuge our sample, and after we centrifuge our sample, we're going to remove the liquid, but now we're not discarding that liquid. Now we're actually transferring that liquid into a cuvette so you can determine the absorbance of your sample. So I have here my sample in a cuvette that I already transferred, and now we can just measure the absorbance for your sample that you have in your cuvette, and that's the absorbance that we're using for the chromate ion. So that absorbance corresponds to the chromate ion that it's actually in solution, that it's in solution because the silver chromate is dissolving to give you that amount of chromate ions in solution. That absorbance is the absorbance that we're using in the graph to get the concentration of the chromate ion. So you're finding that absorbance in your y-axis, you're moving to the line that you have for your graph, and from your line you're moving down to approximate the concentration of your chromate ion in solution.